Okay, we're going to look at our same two blocks. We're recording down here. I hope we're still recording. Yep. All right, good. All right, we're going to look at our two blocks here again, but this is called the Atwood's machine. This is a classic. All right, this is a classic Atwood's machine is what it's called, where you've got a frictionless pulley here, T. You got a tension going up here. You've got an 8 kilogram block here, and it's being pulled this way. You've got an acceleration going down here this way, and you've got a 5 kilogram block over here. Okay, and it's got a tension up here. All right, so here's a tension here, here's a tension here, and here we've got 5 times G, and we've got 8 times G. Well, you know as well as I do that this thing is going to accelerate so that this guy goes up and this guy goes down. All right, so once again, we just want to find the tension and the acceleration. All right, again, make it a train. I always make these guys a train. Shoop. So you've got 8G being pulled here, but this time we have a 5G being pulled here. Okay, all we did was just straighten it out. We've got the same tension here, same tension going here, and this whole system again is accelerating this way. So let's just take the sum of the forces in the x direction. I've got a 5 kilogram block, 8 kilogram block. Sum of the forces in the x direction are equal to 5 plus 8, that's the total mass, times its acceleration a. So we start off with m times a because we're looking at the whole system, and we've got minus 5g plus minus 5g plus t minus t plus 8g. I don't think I'm going to need a calculator. Oh, yes, I am. Plus 8g. Okay, so I wind up with 13a is equal to, the t's cancel, minus 5 plus 8 is 3g. And so the acceleration is 3 over 13 times g. It's a little bit less than the acceleration that we got in this problem. This was 8 over 13. Why is this one greater? Because this one doesn't have a force pulling it back this way. This one doesn't. I was doing it on my computer screen. This one doesn't have a force pulling it back this way. And there. And then now when we solve the problem, we'll look at one block, solve for tension. Look at one block. And let's pick the 5 kilogram block again, just for argument's sake. And it's got a tension going this way. It's got 5G going this way, right? Since there's no friction, I don't have to do all the normal force stuff and all that. And so the sum of the forces in the x direction on this guy, or since this is a 5 kilogram block, is 5. And we've already calculated the acceleration, which is 3 over 13g. 5 times 3 over 13 times g, which is equal to minus 5g plus t. And so the tension is equal to, add 5g to both sides, is equal to 5 times 3 over 13 plus g. 3 over 13g plus g, which is 13 over 13, which comes out to be 16 over 13g, which is equal to 5 times 16 over 13g. Okay, because I just took the 3 over 13 plus the 13 over 13. I did some 5th grade math in my head. All right, so there you go. Not hard. Well, it is. I shouldn't be so glib. This stuff is hard. This stuff is hard. It's physics. It's hard. Okay, to keep, especially when you've never seen it before. There's a classic. Now we're ready for when we add friction.